Hello everyone, my name is Isaac Oni. I'm from Group A. So now I will explain and discuss about the subfields of the civil engineering. So here are some of the subfields of civil engineering. The first one is structural engineering, geotechnical engineering, water resources engineering, and transportation engineering. So civil engineering is the profession of designing and executing structural works that serve the general public. Within the civil engineering profession, there are many subfields to specialize in, such as structural engineering, geotechnical engineering, water resources engineering, transportation engineering, and so on. So each subfield in its unique way contributes to creating, improving, and maintaining the infrastructure that is fundamental to everyday life, economic development, and environmental sustainability. So now I will explain about the structural engineering. Structural engineering involves the design of small and large structures to ensure they can withstand the stresses and pressures of their environments. Structural engineers also ensure that buildings, bridges, and other structures are safe, stable, and resilient against various forces, including gravity, wind, earthquakes, and human activity. The second is geotechnical engineering. It involves the understanding and working with the geological materials upon which structures are built. This includes the study of soil and rock mechanics, understanding how different earth materials behave under various conditions, and designing foundations, earthworks, and tunneling. The third one is water resources engineering. It deals with the management of water supplies, essential to flood protection, irrigation system, and managing natural water resources. An important characteristic that a water resources engineer must have is an understanding of basic water processes, so a clean supply of water can be used for drinking and living. And the last one is transportation engineering. Involves the design of transportation systems such as highways, roads, and public transportation networks, as you can see in the picture. So the operation and maintenance of this transportation system, as well as an understanding of traffic control system, are also parts of the responsibilities of a transportation engineer. So that's all from me. Thank you.
Assignment 1, Group A, Introduction to Civil and Structural Engineering. So, this assignment is about scholars in UTM JD. Okay. In 1989, the Scholars Inn started out as a guest house consisting of 7 two-bedroom homes scattered among a residential college to house guests from UTM. In 1992, the Scholars Inn Hotel remodeled 88 single rooms as part of our service room to meet the increasing demand. They relocated to the current facility in 2004 as part of UTM's transitions, and they still operate as a non-profit public organization that offers on-campus housing for visitors, visiting researchers, speakers, parents of UTM students, and other campus visitors. They continuously strive to provide their visitors with an unforgettable stay. Okay, the architectural concept is integrated with academic environment. The goal is to keep the hotel's own character while blending in with the neighboring academic community. Second, functionality and comfort. The architectural idea incorporates well-planned guest room, common areas, and facilities. And the third one, community engagement. The Scholar Inn has area intended to promote social interaction among visitors, strengthening the feeling of community in UTM campus. Next is the structural system. Scholars Inn uses the concept of reinforced concrete frame in which steel is embedded and the two materials act together in resisting forces, while the structural element is long-span beams, which improve the space aesthetic appeal, creates a dynamic and adaptable environment inside the structure, and encouraging an open feeling. The next one is rooftop solar panel. It is a popular and sustainable way to produce electricity. The last one is the material used. First is glass. It is to cover the panel of the window with the ability to both let light into the room while at the same time keeping inclement weather outside. Second is wood. Wood has low heat conductivity, small bulk density, relatively high strength, and amenability to mechanical work. And the last one is concrete. Concrete is not burned and it is fire-resistant material. Besides, it is useful for commercial building projects as it is available in many colors or finishes.
Second assignment from Group A, Section 1 discuss about issues on geological, geotechnical and transportation engineering along with the real-life cases about the issues. Firstly, issues related to the geological engineering. One of the factors of the issues that occur in geological engineering is high rainfall and erosion. Tropical climate often experience heavy rainfall, leading to soil erosion and instability. This can affect the stability of slope, embankment, and foundation, requiring engineers to design structure that can withstand this erosive force. Next is flooding and drainage. Tropical region often experience seasonal flooding, exacerbated by heavy rainfall and topographical factors. Proper drainage systems are crucial to prevent water lodging and structural damage. Engineers must design effective drainage solution to manage excess water. As for the solution, we can do site investigation and geotechnical studies. We can conduct through site investigation and geotechnical studies to understand the local geological condition, analyze soil properties including soil type, moisture content, and expansive characteristics to inform foundation design. After that, we can also give more attention to fluid management and drainage by developing comprehensive drainage system to manage excess water during heavy rainfall and flooding. Incorporate green infrastructure and sustainable drainage practice to enhance water absorption and reduce. Furthermore, we investigate the issues that occur in geotechnical engineering. One of the factors are foundation settlement. Consider a construction site where a hillside needs to be excavated for a new building. The geotechnical engineer must assess the slope stability to prevent landslide or slope failure during and after construction. Factors such as soil type, slope angle, groundwater condition, and potential loading need to be considered. Next is slope stability analysis. Suppose a building experiences excessive settlement, including structural damage. This settlement can result in inadequate foundation design, poor soil compaction, or variation in soil properties beneath the foundation. As for the solution, we can perform stability analysis. Perform a slope stability analysis using method like the Bishop method or the limit equilibrium method. The engineer might recommend measures such as installing retaining wall, soil reinforcement, and adjusting the slope angle to ensure stability. Next, we can also do investigation that conduct a tour of geotechnical investigation to understand the soil condition. Implement proper foundation design technique, including the use of shallow or deep foundation based on soil bearing capacity. If settlement has already occurred, mitigation measures may include underpinning or soil improvement technique. Moving on to the real-life cases, issues on geotechnical elaborate on the engineering problem encountered in construction projects that have been carried out by PWD, namely Core Facilities Building of Polytechnic Kota Kinabalu in Sabah and Hospital Tunku Ampuan Rahmah Integration Complex in Klang, Selangor. Instability of the ground during construction work had caused delay in cost overrun in completion of the project in Selangor, whereas occurrence of continuous post-construction settlement has affected in integrity and serviceability of the building in Sabah. Moreover, this assignment also talks about the issues on transportation engineering. As for the issues, it involves tropical storm and hurricane, where structures such as bridge and signage must be designed to resist the high wind associated with tropical storm and hurricane. Wind-borne debris during storm can potentially endanger transportation infrastructure. Besides, high temperature and sunset exposure also make an impact. High temperature can cause concrete surface to deteriorate, creating cracking and rotting. Also, intense sunlight can also expedite the aging of material, shortening their lifespan. Extreme heat can cause significant thermal expansion and contraction of root and bridge components, resulting in structural distress and deformation. The solution for the issues are design structure to withstand the hard wind and flooding caused by tropical storm, to improve public safety during extreme weather occurrence, implement early warning system and evacuation routes, use heat-resistant asphalt material and cool pavement technologies. Proper maintenance techniques such as regular sealing and resurfacing can help extend the life of roadways. Temperature-induced damage can also be mitigated by regular maintenance and timely repairs. One of the real-life issue is the Sentosa Gateway Tunnel, where a key aspect of Singapore's effort to enhance connectivity. Officially referred to as the Sentosa Gateway Tunnel and Bridge, it comprises an underground road tunnel beneath the Keppel Harbour Expressway and a bridge connecting the mainland to Sentosa Island. The tunnel construction involves handling complex geological and geotechnical challenge given Singapore's soft marine clay soil and hard water table.
Then we move on to assignment 1 for Group B, which is about hydraulic and water resources. The first thing is about climate changes. Climate change refers to long-term changes in weather, oceans, land, and ice sheets over decades or longer, usually at least 30 years. It can be caused by natural processes like the sun's radiation or human influences such as changes in the atmosphere, land use, food production, and transportation. Natural processes such as solar radiation contribute to climate change by affecting the Earth's climate. Food production, distribution, and packaging also contribute to greenhouse gas emission. The largest portion of food-related greenhouse gases come from agriculture and land use, including methane, nitrous oxide, and carbon dioxide. Transportation networks powered by fossil fuels contribute to climate change infrastructure by producing approximately 25% of carbon dioxide emission worldwide. Next, what is the relation to SDGs, which is Sustainable Development Goals by the United Nations? It is related to the SDG 6, which is about clean water and sanitation for all. The goal is to ensure the availability and sustainable management of water sanitation for all. And the second one is SDG 30th, which is climate action, which is to limit and adapt to climate changes. The second one is about tsunami. A tsunami is a long wave that originates from the sea and undergoes shoaling as it approaches land. Shoaling increases wave amplitude as it transitions from deep to shallow water, particularly near the coast. The 2004 Boxing Day tsunami, a devastating tsunami, reached height of up to 30 meters, causing immense loss of life and property. Tsunamis are sometimes referred to as tidal wave and can vary in height from a few centimeters to over 30 meters. It is crucial to be aware that not every earthquake or volcanic eruption will cause a tsunami or cause significant damage. Okay, what is shoaling process? Wave shoaling is the change in wave shape and behavior as waves propagate into water of decreasing depth, causing a decrease in speed and wavelength while increasing the wave height. This process is unaffected by water depth in deep water but affected in shallower water. Waves shift as they enter shallow water, with crest becoming sharper and throat flattening and widening due to depth change. Wave shoaling can occur in any wave controlled by the seabed, both linear and non-linear. It is most readily observed for prolonged period of swell approaching a coastline. Tsunami waves become dangerous only when they approach the coast, as wave shoaling increases as the water becomes shallow. This phenomenon is significant in coastal areas due to the force generated when the seabed becomes shallow. Even when tsunamis have small amplitude, they can shoal up to several meters high when they hit shallow water. So that's all for assignment 1.
Next, moving on to the second assignment of the water and energy consumption. We will discuss about the average consumption and how to calculate the average energy consumption per month dash percent per kilowatt hour and strategies to reduce the consumption of water and energy. Next, this table show the average water consumption of Surau Ainur Seri Pagi and Masjid Al Hasanah. Secondly, this table show the average energy consumption of Surau Ainur Seri Pagi and Masjid Al Hasanah. After that, this is the table of average energy consumption per month and percent of Surau Pagi Ainur and Masjid Al Hasanah. Next, we will talk about the strategies to reduce the consumption of water and energy. Firstly, water cycle strategy. Solving the problem of excess water consumption can be provided by good tap-controlled design or grey water recycling. In order to reduce water usage in ablution practice, we can introduce a new design for ablution tube or other innovation. Next, automation, control and monitoring strategy. Automation of control and monitoring process of most facilities and energy consumption such as electricity, heat, water described in this work. By using sensor and actuators throughout the mosque building, human intervention can be significantly reduced, which can significantly reduce energy waste due to human error. Extracting knowledge or delivering information through statistical analysis and machine learning approach. This action is also considered important due to its ability to conduct prediction of future issues, pattern recognition, data classification and clustering, and also insightful information presentation based on current collected data as discussed in the previous work. As a consequence, the mosque service to the visitor can adapt with any situation and condition. Lastly, heating, ventilation and air conditioning strategy. The HVAC system main purpose is to meet the thermal comfort and certain criteria. HVAC activated sensor technology also offers significant benefits, supports the sustainability of mosques. Therefore, when there are no prayers, the system will automatically turn off.
And so, we will discuss the summary of all the subfields of civil engineering. So, the first subfield assignment is the structural engineering from Group 8 K1S1. We discuss about the structure of a building. The building that we chose is Scholz Inn, and we discuss about the structural system, the structural element, materials used, and interesting features that we can add to the building. For the second subfield assignment is the geological, geotechnical, and transportation engineering that has been made from Group 8 K1S1 also. We discuss about the issues on geological, the issues on geotechnical, the issues on transportation, and the real life cases and ways to prevent it. As for the third subfield assignment that has been produced from Group 8 K1S2, that is hydraulics and water resources engineering. They collect the data of water and energy consumption of two buildings and then calculate the average of it and then compare the data of the two buildings. After that, they also discuss on how to reduce the water and energy consumptions of the buildings. The last subfield assignment is environmental engineering that is also been produced by Group 8 K1S2. They discussed about the causes of climate change and explain the statement and relate it to the Sustainable Development Goals (SDGs) that can be applied to the whole world. They also discuss on how the tsunami occurs and the Shaolin process.
For the extra question, the first issue is the Yuban heat island effect. The heat absorption and retention of ural area is less than the city due to the plant transpiration and water evaporation from the soil and cause the difference of water penetration. We can solve this issue through using green infrastructure. For example, incorporate more green space, parks and urban forests to increase vegetation cover, which helps in reducing heat absorption and promoting cooling through evapotranspiration. Besides, we can also using cool roof and pavements. Implementing cool roof technologies and reflective pavements can mitigate UHI by reflecting more sunlight and absorbing less heat. Due to factors such as climate change, rising seawater levels, and excessive groundwater extraction, seawater intrusion is becoming a critical issue in coastal regions. This phenomenon can contaminate freshwater aquifers, affecting the availability of potable water resource for both urban and rural communities. The solution is maintaining water conservation measures. Government can promote water conservation practices to reduce the demand for groundwater, thus lowering the risk of seawater intrusion. These include the use of efficient irrigation systems and the implementation of water reuse technologies. The last issue is the earthquake. Earthquake-prone regions face the challenge of ensuring the structural integrity of building and infrastructure during seismic events. In recent years, the increased frequency and severity of earthquakes in certain areas like Philippines, China, and Turkey have highlighted the need for robust engineering solutions. The first solution is using seismic retrofitting. Strengthen existing structure through retrofitting technologies such as adding base insulators or dampers to exchange their ability to withstand seismic force. We can also advance new building materials. Develop and use advanced materials such as fiber reinforced composites or shape membrane alloys to construct buildings with enhanced seismic resilience. In a nutshell, these issues require a multidisciplinary approach involving collaboration between engineers, urban planners, policymakers, and environmental scientists. Additionally, ongoing research and technology advancement play a crucial role in finding innovative solutions to this emerging challenge in civil engineering.